Okay, in this video, we're going to explore the wording conclusion and finding the critical z-scores. Okay, so in the previous case, how do I find the confidence interval for the example that we have? Since the sample mean is, no, I'm sorry, the sample proportion is 0.48, and we want to find the 95% of confidence interval. So all we need to do is use 0.48 plus or minus the z-score times p hat and n. Let me be mod. This is the formula. So p hat, which is the sample proportion, is equal to 0.48 plus or minus the z-score, and we found out that in the last video, since we want it to be 95% of confidence interval, it's going to be 1.96 square root of 0.48 p hat. Q hat is 0.52 divided by 2500. So this number, we will receive a two number. One number is going to be the upper bound of the range. The small number, which is a subtracting the number, is going to be the lower bound of the range. When you find it, you will get a confidence interval which is 49.4%. The upper bound is 49.96. So since the z-score contains 95% of the data, so we call this is 95% of confidence of interval, which is the range that is going to lie, the true value is going to lie into that range. One thing that I need to emphasize, since we want the true population proportion, lies in the range. In this case, this is going to be the p, not p hat. 95% of a confidence of interval, not p hat. The p hat is what we are using to estimate the confidence of interval. Okay, so when it comes to the word of the confidence interval, that contains three parts. One is the levels of confidence. The most common one that we've seen is called 95% of confidence of interval. Sometimes we want it to be even higher, it's 99% of confidence of interval. That means how many percent that you want to be sure that the true population proportion lies in that range. We want to be 95% of sure, we want to be 99% of sure. Second part is the range of the values, which means we found the lower and upper bound. The third important thing is this is the description of the population proportion. Which means it's the all, not just the sample proportion. It's our p, not p hat. Just remember that what I'm talking about here, we use this p, we use the confidence of interval to estimate our p, which means we use the sample to estimate our old or population proportion. Okay, so here's some example of exercise. A, let's say if this is a truth or false statement. 48% of all HR professionals use social networking site to research the job applicants. So 48% is our p-hat because we surveyed 2,500 people, not all of the professionals, right? And then we get back the result is 14.8% of those 2,500 people say they use social networking site to research job applicant. So that indicates that this is a p-hat. And then, so that means this is a false statement. It's not a confidence interval statement because we know that the sample proportion is not equals to the population proportion. Another way that you can see that, hey, they tell you that 48% of all the professional, that means they want to let that 48% to become the population proportion. But this is wrong because that 14A is come from a survey with a sample size of 2,500. So remember that we can't just use the concept wrong. The sample proportion is not equal to population proportion. Sample proportion is p hat, population proportion is p. Okay, B, the statement says it is probably true that 48% of all HR professionals use social networking site to research job applicants. Again, this is similar to what the A statements, which means they miss understanding of the sample proportion and the population proportion. They still use the sample proportion. Oops, I spelled it wrong. %48 is our sample proportion. They still use that as a population proportion. That means it's wrong. Okay, see, we don't know exactly what proportion of all HR professionals use the social networking. So the first sentence is correct because you can survey the whole HR professional, right? So the first sentence is wrong, but we know that it's between 46% and 50%. Okay, this is the range of how sure they, this is the range, which is the second part, the range of the value. They have the upper bound and lower bound, 46% and 50%. But they say they know. That means they are 100% sure about that. But during our calculation, our 46% to 50%, which is here, they round this up. We know that this is 95% of confidence of interval. This is not 100% sure that 46% to 50% of a professional will use the social networking. So that's why it's wrong. You are not 100% sure. You are only 95% of sure that, hey, it's between 46% to 50%. D, we don't know exactly what proportion of all HR professionals use the social networking site to search job applicant. It's probably between 46% to 50%. So now they have the range, and the first part is correct because they say they don't know exactly the population proportion, right? But however, this part probably is too vague because by the time we calculate 46% to 50%, we already know that, hey, the confidence of interval, the level of confidence is going to be 95%. So we need to use that. That means they're missing the first part. So that means it's wrong. They didn't give enough certainty. Okay, E. We are 95% confident that between, look, check the first one, between 14.6 and 50%. Okay, this is the second condition of all HR professional using the social networking. So of all HR professional, that means we use this estimate the confidence of interval to estimate the population proportion P. So that means it satisfies the third condition. So that means this is a true statement. Now, next part is how do we find the z-score for 99% of confidence of interval. First of all, if you want it to be 99% of confidence, that means you want 99% of data is in the middle of the bell curve, and then totally this 2n contains 1% of data. Since the normal distribution is symmetric, so that means each n contains 0.5% of the data. Now, we know that z-score follows the standard normal distribution with the mean 0 and 1. Now, we can try to use GeoGebra to calculate that. So we want this to be only 0.5%. So that means this is going to be 0.005. So x is going to be 2.5758. So since standard normal distribution is symmetric, that means the other end, if we're trying to find 0.05, it's going to be a negative 2.5758. So we write this down. So we write down our answer. So the z-score in this case is going to be a positive or negative 2.578. So similarly to the 95% confidence of interval, we did that earlier. The cutoff value in here is 1.96. This is 1.96 below the mean. So it's 1.96. So please try to do this, pause the video, try to find the z-score for 19% of confidence of interval and 80% confidence of interval. Because in the test, if you forget, you can still find it by yourself through GeoGebra. Okay, so in the middle, we want it to be 19%. So in this 2n, we want it to be totally 10%. So that means each n, we want it to be 10%. Oh, sorry, we want it to be 5%. Totally is 10%, so that means if we divide it by 2, each part is 5%. So the z-score, by calculating that, I got 1.6449. So 80% confidence of interval. We want 80% of data in the center. Each n contains 10%. So I got 1.2816 for the z-score. I just show you the answer here, but I really want you to calculate it by yourself. Okay, in next video, we will do more practice on how to constructing the confidence of interval.